Today we'll be showing the goodness of fit test.
The purpose of a goodness of fit test is to perform a hypothesis test for the distribution of a variable. The following assumptions must be met. 1. All expected frequencies are 1 or greater. 2. At most, 20% of the expected frequencies are less than 5. 3. The sample must be a simple random sample.
Step 1. The null and alternative hypotheses are HO. The variable has the specified distribution. HA. The variable does not have the specified distribution. Step 2. Calculate the expected frequency for each possible value of the variable by using the formula E equals NP, where N is the sample size and P is the relative frequency, or probability, given for the value in the null hypothesis. Step 3. Determine whether the expected frequencies satisfy assumptions 1 and 2. If they do not, this procedure should not be used. Step 4. Decide on the significance level alpha. Step 5. Compute the value of the test statistic x squared equals sigma O minus E squared divided by E, where O and E represent observed and expected frequencies. Denote the value of the test statistic x squared O.
Step 6. The x squared statistics had degrees of freedom equals k minus 1, where k is the number of possible values for the variable. Use table E to estimate p-value. Step 7. If p is less than or equal to alpha, reject H null. Otherwise, do not reject H null. Step 8. Interpret the results of the hypothesis test.
Example 13.3. Violent crimes. Table 13.5 repeats the relative frequency distribution for violent crimes in the U.S. in the year 2000. A random sample of 500 violent crime reports from last year yielded the frequency distribution shown in 13.6. At the 5% significance level, does the data provide sufficient evidence to conclude that last year's violent crime distribution is different from the 2000 distribution?
Step 1. The null and alternative hypotheses are HO, last year's violent crime distribution equals 2000. HA, last year's violent crime distribution is not equal to 2000. Step 2. We have n equals 500, and the relative frequencies for the null hypothesis are shown in the second column of table 13.5. Step 3. 1. Are all expected frequencies 1 or greater? Yes. 2. Are at most 20% of the expected frequencies less than 5? Yes, none of them are. Step 4. We are able to perform the hypothesis test at the 5% significance level, and consequently, we have alpha equals 0.05. Step 5. X squared equals sigma O minus E squared divided by E, which equals 3.555 in this case.
Step 6. X squared equals 3.555. K equals 4. The degrees of freedom equals k minus 1, which equals 3. So, the p-value is greater than 0.10. Step 7. Because p is greater than 0.10, we reject HO. Step 8. At the 5% significance level, the data does not provide sufficient evidence to conclude that last year's violent crime distribution differs from the 2000 distribution.
Now we are going to show you how to do this on a calculator. In list 1, you input your observed frequencies. In list 2, you take your expected relative frequencies, multiply each by 500 because each is a percentage of your sample. For list 3, denote it as list 1 minus list 2, quantity squared divided by list 2. Then find sum in your catalog, which is found by second 0. Push enter when you highlight sum. Then push second, number 3, and hit enter. Then you go to second distribution and goes down to x squared CDF. Once number 7 in this case is highlighted, push enter. Now we want to take what our sum was for list 3, so second answer, comma, and we want to find this using a very large number, so say 1 times 10 to the 99th, and comma, degrees of freedom, which in this case is 3. Hit close parentheses and hit enter. And then we get our p-value, which tells us we can reject HO. And that's how you do it on your calculator. This has been Goodness of Fit Test with your friends Antonio and Jazzy. Hope you enjoyed it.